Hi everyone, welcome. Here are the big takeaways from these chapters, Chapter 11 on confounding and obscuring variables, and Chapter 14 on replication, generalization, and the real world. First big takeaway, we'll talk about experiment evaluation. After the research design is complete and all these design decisions have been made, that is, what are my variables, how am I going to measure them, things like that, the reader of any published research article is evaluating the validity of the study results and the implications being argued about those study results, right? This type of experiment evaluation applies to any research design, whether results come from correlational findings, like a reliable predictive relationship between variables or the existence of risk factors, or experimental findings, that is, the existence of a cause and effect relationship. This type of experiment evaluation talked about in this chapter is the last step. As a last step, applies to any research design. So here in these chapters, we take a step away from the details of research design to kind of look at the big picture. And that hinges upon two decisions. Will the end of study results be believable? For example, when an experiment results in data arguing cause and effect between two variables, is that a credible, believable claim? And number two, will the results generalize? Number one, will the results be believable? Number two, will the results generalize from your carefully planned study to the real world and people represented in your sample? So, takeaway number two, experiment evaluation then means answering two questions that we refer to as internal validity, you've heard before, and a new term, external validity. Internal validity asks, have we eliminated all other possible explanations for the changes observed in our dependent variable, so that it follows logically that the independent variable must be the sole cause of any changes observed in the dependent variable. In other words, have I eliminated all the influence of possible extraneous variables? Internal validity evaluates the certainty of our cause and effect inference in any experiment. While this same concept applies to correlational studies as well, remember that experiments explicitly attempt to control for extraneous variables as alternative explanations for any observed outcomes in the dependent variable. Internal validity, you've heard of before. The counterpart to that in this chapter is in experiment evaluation, is our new topic about questioning external validity, which asks, can your experimental results, when the study's over, can your experimental results now be applied to populations and situations other than those specific people who participated in your specific experiment? Here, we evaluate the external relevance, if you will, of study results. Do your study results relate to real life behavior and real life events? Here we evaluate the external relevance. This is a pretty important question, this external relevance, to ask. When we recognize that an experiment occurs in a necessarily artificial environment because we explicitly attempt to control for the influence of extraneous variables, meaning that the researcher is trying to remove a known, a variable, multiple variables, known to influence the experiment. So think about this. This results in an experiment that is a bit removed from real-life extraneous variables, right? This whole concept of trying to control for extraneous variables is somewhat artificial. So when the study is complete, external validity is asking the question, now have we removed our experiment too far from real life and the way variables really operate in the real world? The truth is, controlling too many extraneous variables turns out to be a bad thing because your study results will not generalize to the real world. Note that the question of external validity also hinges upon whether or not the researcher has gathered an adequately representative sample. That is, it is representative of the larger population to whom we wish to generalize the results. Now, the final takeaway, number 3 in this chapter, this inverse relationship between internal validity and external validity. We discover that as one increases, the other one decreases. And as the other one increases, the first one decreases. Good experimental control control of extraneous variables, leads to high internal validity. And that's a good thing. That means putting in place control processes or making design decisions that control for extraneous variables. This leads to good internal validity. But realize that when we choose to eliminate any known influence, we are choosing to eliminate a part of real life, aren't we? So it's critical that we not go too far and eliminate too many extraneous variables, thereby eliminating too much of real life. This would result in an experiment with low external validity. High internal validity makes low external validity. See the inverse relationship there? As one increases, the other decreases. Everything I do to increase internal validity also decreases external validity. External validity asks the question, can your experimental results be generalized to other populations and situations beyond the specific sample that I studied? This is after all design decisions have been made, after various extreme characteristics of the population have been screened out of your study sample, and after our experimental groups have been carefully balanced on certain characteristics. Every attempt you make to control for an extraneous variable increases internal validity, but it also moves one step away from real life and therefore decreases external validity. And this is the point. In practice, you may find that the steps you take to increase one type of validity decrease the other. A tightly controlled laboratory experiment affords a psychologist a relatively high degree of internal validity. That's a good thing. Note that a laboratory researcher, think of like a university professor, designs research that favors internal validity because proving cause and effect is a high priority. Their findings, however, may not generalize. Thus, external validity may be reduced. By the way, a clinical psychologist or an applied researcher, think of a researcher who's working in a clinic or in a hospital setting. They would design research the other way. They would design research that favors external validity because reflecting the complexities of real life is a high priority. So there is this inverse relationship. As one increases, the other decreases. Often the best we can do is to reach a compromise on the relative amounts of internal validity and external validity in our research. So in summary, the big takeaways from Chapter 11 on confounding and obscuring variables and Chapter 14 on replication, generalization, and the real world are these. Number one, experiment evaluation happens after the research design is complete and all those design decisions have been made, like what are my variables, how do I measure them, how do I control for extraneous variables, things like that. Number two, experiment evaluation means answering two questions that we refer to as internal validity and a new term, external validity. Do the results of my study still apply to real life? Number three, big takeaway, in practice you'll find that the steps that you take to increase one type of validity tend to decrease the others. One goes up, the other one goes down, and vice versa. Often the best we can do is reach a compromise on the relative amounts of each. Those are the big takeaways, guys, from these two chapters. Thank you.